Okay, example 6. Find the point of the parabola 2 parentheses y minus 4 equals x minus 2 squared that's closest to the point 4 comma 1. Alright, so basically the same type of question the last one was, except now we got a parabola instead of a line. Again, getting y equals is probably better than having this standard form they got us into, because again, if y equals something about x, we can do a substitution. So let me just multiply that through. So 2y minus 8 is equal to x squared minus 4x plus 4. Move the 8 over, so we're going to get 2y is equal to x squared minus 4x plus 12. Divide by 2, we're going to get y is equal to 1/2 x squared minus 2x plus 6. That's my parabola equation. If we recall how to graph a parabola, if I do negative b over 2a, negative b, change the sign, 2 times 1/2 is 1. The vertex value of the coordinate of the vertex is 2. So if I did like a little xy chart here, and I wanted to pick, usually pick 5 points. If I picked 1 and 0 and 3 and 4, that would be pretty good, right? I need to get points on the parabola. I just type in my equation, y equals 1/2 x squared, was it minus 4x?
Minus 2x.
Minus 2x? Plus 6. Alright, and then I type in my 5 numbers there. 0, 1, 2, 3, 4. 0, 6, 1 comma 4.5, 2 comma 4, 3 comma 4.5, and 4 comma 6. We get the expected symmetry we get for graphing a parabola, right? I found the correct vertex value because the symmetry is there on either side of it. So if I plot the graph here, x-axis, y-axis. So 0 comma 6, 1 comma 4.5, 2 comma 4, 3 comma 4.5, and 4 comma 6. There's our parabola. And the point that we want, 1, 2, 3, 4, 1, we want to be closest to this point. So again, if I just imagine some point x, y, I'm going to kind of ballpark it right about here, x comma y. It doesn't really matter where you put the point, just so you can get a visual of it, you can see it. And if I connect the dots there we go. Doesn't look very right angly there, but so it's probably not the right point. But it's in the general area, but right? Once again, we're looking at some distance between those points. So this is the distance between the points. This point's 4 comma 1, that point's x comma y. Once again, my distance formula is what it always is. Distance equals the square root of x minus x squared plus y minus y squared. In this case, x minus 4 and y minus 1. I recommend getting it looking like that first before you start substituting stuff in. Just have a friendly looking equation on your paper first before you substitute. And then we go ahead and do this. We substitute like we did before. So this time y equals this expression. So this y gets changed with that expression. So d ends up equaling the square root of x minus 4 squared plus, it'll be 1/2 x squared minus 2x plus 5 squared. The plus 6 and the minus 1 make a plus 5. The x's don't get affected by that because there's no like terms with it. So little d is that. So big D is going to be just the inside part. And I'm going to go ahead and square these. X squared minus 8x plus 16, that's easy. This other one squared is not quite as easy, right? So I might, on a scratch sheet of paper, do that product. 1/2 x squared minus 2x minus 5 times 1/2 x squared minus 2x minus 5, or plus 5. Right, so 1/2 x squared times 1/2 x squared is 1/4 x to the 4th. 1/2 x squared times negative 2x is minus x cubed. 1/2 x squared times 5 is 5/2 x squared. Negative 2x times 1/2 x squared is negative x cubed. Negative 2x times negative 2x is positive 4x squared. Negative 2x times 5 is negative 10x. 5 times 1/2 x squared is 5 halves x squared. 5 times negative 2x is negative 10x, and 5 times 5 is 25. 1/4 x to the 4th minus 2x cubed. That'll be 5 plus 4, so a total of 9x squared minus 20x plus 25. So that plus that. Combine like terms, we end up with 1/4 x to the 4th minus 2x cubed plus 10x squared minus 28x plus 41. Just polynomial arithmetic there, so multiply them out, add like terms, right? So there's our big D in terms of x, so now we just have to differentiate. D prime is going to equal 1x cubed minus
May I have your
6x
attention for
squared
one
plus
announcement?
20x minus 28.
Junior, please remember to report to Mr. Dittmer's room for your testing during third period. That was seniors, report to Mr. Dittmer's room for testing third period. Thank you.
That'll make for a better video there. So it's a cubic equation. We don't know how to solve a cubic equation off the top of our head. So doing a graph, zoom 6, just to kind of get a feel for where the answers are. Maybe, there we go. It only crosses once, so that's probably the right answer. Calculate intersection, calculate 0. Left bound 0, let's go right bound 4, guess 2.5, and 2.4857. Also, looking at the graph, this is the graph of the derivative. It goes negative to critical number to positive, so it decreases, then it increases, right? So just a visual representation of the derivative tells us increase, decrease, that's a minimum. That represents what we're looking for, so we don't have to go through the whole interval thing this time. We've got that figured out. So then we just had to figure out what y is, and y is based on the equation, which I've erased. It was 1/2 x squared minus 4x
Minus 2x.
2x plus 6. So if you just put in 2.4857, I get 4.11795. 4.1180. So that would be the point. And again, if I go back here to this graph, 2.4857, comma 4.1180 would be about here. That was pretty close to my guess, but again, calculus finds you the exact answer. And that would be it. That right is an ordered pair. Bell rang, so we won't worry about that this time.